Here we go. So we are on 3C.11, secant, cosecant, and cotangent functions, okay? These are our reciprocal trig functions. So with our reciprocal trig functions, they're going to behave the opposite of their original function, sine, cosine, and tangent. Remember when you're doing the inverse of a function, that means you're switching your input and your output, correct? For trig, we typically do not say inverse because that refers to us finding um, our degree value instead of finding the ratio. And so when we say inverse, that's our arctan, arcsine, arccosine. But so we call them reciprocal functions because that's literally the relationship of the identity. Y'all remember that's the identity. We flip our x's and y's, we reciprocate. So we call it the reciprocal. So these functions are going to just follow along with sine, cosine, and tangent. It's just that we have to take into case that when we flip something, it has a denominator now, right? And our denominator can't equal what? 0. Because of that reciprocating, we now have created discontinuities in our function. And those discontinuities are called asymptotes, vertical asymptotes. All right, so our reciprocal functions are secant is 1 over cosine x. If you're using Desmos, you can just type in secant x. If you're using the handheld, you have to type in 1 over cosine x. Okay, so if you're using Desmos, you can type in this just fine. If it's the handheld, you actually have to type it in as is reciprocal. Okay, so for secant x, it's 1 over cosine x, and cosine x cannot equal 0. Okay, so whatever makes cosine x equal to 0 doesn't work. So thinking about our unit circle, on our unit circle, when is cosine equal to 0? At what angles? There you go. So we know that we can't use pi over 2, and we can't use 3 pi over 2 because that's where cosine equals 0. That's where your x value is 0, correct? Yeah, okay. And then that would go for all of its corresponding angles, correct? Cosecant. Cosecant is the reciprocal of sine, okay? So now we're thinking about, all right, on the unit circle, when does sine equal 0? Sine equals 0 at, perfect, 0, 2 pi, and at pi. So we know that we can't use those values. They're going to be asymptotes. They're going to be some problems. Okay, next we have cotangent. Cotangent is the reciprocal of tangent, okay? And so tangent is a little tricky because tangent is already a ratio itself. Does that make sense? Tangent is already a ratio, and that ratio is normally sine over x. So therefore, cotangent is going to be cosine over sine. Okay, that means that its restrictions depend on sine x. So its restrictions are still the same as sine x. So it's going to be at 0, 2 pi, and pi, following the same rules as sine. Okay, so at all of these multiples of these places is where we're going to have our vertical asymptotes. So whenever the denominator is 0, that's why we have those vertical asymptotes, those imaginary boundary lines that we will not be able to cross. Okay, all right, so let's look here. So here's secant and cosecant. When you look at secant and cosecant, do you see their original functions as well? So when you look at secant, you can see the cosine function. Do y'all see that? This is invisible, but you're still doing the cosine. The secant comes from where it is at 0, and then the shape, then your asymptotes come from where it's at 0, and then the shape follows your maximums and your minimums. So drawing them and identifying them is actually not terrible as long as you draw and identify a sine and cosine. All right. What I typically do is I outline the sine and cosine graph, find it 0, so that's my asymptote, and then I find my max and my mins, and those are going to be my curves of my graph. Okay. When you look at these graphs, they're just like any other time you're finding the inverse of a function. Your sine, your domain and your range are going to switch. Okay. So for sine and cosine, the domain was all real numbers, right? From negative infinity to positive infinity, because you can keep going around that circle over and over and over, and then reverse over and over and over, right? However, its range was from -1 to 1. Do you remember that? So we only could go as low as -1, as high as 1, because on a unit circle, that was our max and our high value, correct? Now, when you look here, those two things have switched, okay? So our domain, our range is now infinite because it's going forever up and forever down, okay? Our range is now infinite. However, our domain has changed. Our domain is based on a pattern of integers. So our domain is infinite. However, it has a pattern of where I have asymptotes. So when you have those patterns of asymptotes, that's where that plus pi k comes in again. Okay. And so depending on where it's at, so for what's this graph called? Secant. For secant, it's going to be everywhere that you have a 0, that's where its domain is undefined. So everywhere we have a 0 is at pi over 2. So it's pi over 2 plus pi k. So every odd half pi, that's our asymptote. On sine, it's at every pi. So it's at 0, 1, 2, 3, 4, 5, 6, 7. And that's why it would be here. So let's look at our whole chart. And our next one is cotangent. Cotangent works a little different. Cotangent, as you can see, it just kind of basically flipped a little bit, but it's going to be based off of our x's and y switching. So it's going to follow the same restrictions as sine. And that's because sine is now your denominator. So everywhere that sine equals 0, which is at our 0 and pi and 2 pi and 3 pi and 4 pi and 5 pi, that's where its asymptotes are going to be for tangent. And the cotangent function is decreasing from left to right. So it's just going to follow that, and it's going to be decreasing from left to right. Your negative pi over 2, that's where your 0 is. And that's because that's when you have 0 in the numerator as cosine. So everywhere that cosine is 0, that's where your x-intercept is, and you're just following the curve. They do not have to be perfect. You're not actually graphing. You're going to be having to use the graph and find them. That's it, okay? You're not creating graphs because it's not part of your FRQ. All right, so let's look at some examples of what some of these questions may look like and how we use our knowledge in understanding the graphs to answer them. So here we have 3 secant 2x, which of the following is a vertical asymptote of the graph. So when we look here, you're going to have to do this without a calculator, okay? This is a non-calculator part. It's wanting you to be able to create the graph without a calculator, all right? The best way to think of this is I'm going to show it to you in a calculator so you can see from here on out what you're visualizing. Is to think of it as its reciprocal function. So we're going to start off visualizing it as a cosine function, which we've practiced how to graph a cosine function, right? Identifying our amplitude and identifying our horizontal stretch and compression, right? That dilation value. So we know that if this was a cosine function, our amp would be 3 and our stretch and compression horizontally would be 2, right? So that means that we're cutting our time in half on our period, correct? So we already know how to do this as a cosine. And I'm going to show you that as long as you treat it like a cosine, you can find it as a sine. So I'm going to model it using the handy dandy calculator though, just so you can see the visual and tie it together is my hope. That is not y'all. I just need the calculator. All right. So when I say visualize it as cosine, so I'm going to type this in as a cosine function. So we're going to type it in as 3 cosine of 2x. Okay. I'm going to adjust. Also, the settings that they put make my windows super duper tiny. So like I can't see anymore the values of anything. All right, on the x-axis, I want you to count by pi. No, that's not where the scale factor is. Is this the step? Pi divided by 4. There she goes. And on the y-axis, that's fine. We can see the amp just fine. All right, so when we look at this graph, you can clearly see that this where we have our zeros at, right? Everywhere that there's a zero, that now becomes your asymptote for its reciprocal. Okay, so we have a zero here at pi over 4. We have a zero here at 3 pi over 4. We have a zero here at 5 pi over 4. That's where your asymptote comes. So when it asks you which of the following is a vertical asymptote, your vertical asymptotes are the zeros of its reciprocal. Does that make sense? So looking at your multiple choice options, can you easily identify what is my vertical asymptote? And where's my vertical asymptote we're going to be at? Pi over 4. Do you see that in our thing? What I'm talking about? Do we remember how to graph or create our cosine without this? Or do I need to review how to do it without the calculator? Review? Okay. All right. So we saw the visual as to how it works. Now, remember I told you we're going to think of it as its cosine. So we have 3 cosine of 2x. That 3 is my amplitude, correct? That's my distance from my midline. Well, my midline is at 0. Why is my midline at 0? Because I have no d value. There's nothing that's making me go up and down. So my mid is at 0. And then my 2, that's part of my period, correct? That's my b. So the period equals 2 pi over my b, correct? And I know b is 2, so 2 pi over 2, which means my period is pi. Agree? Do we all remember that? So when we're looking for our information, we know that as cosine, it's not asking about the height or anything. So do I really need to worry about the amp? No, I just got to worry about what's happening on the x-axis. So we know it goes from 0 to pi. And remember, at this point, you're just dividing it into quarters. I'm going to divide in half. What's half of pi? Pi over 2. What's half of pi over 2? What's half of 50 cents? Quarter. And so we know these two add together is going to make 3/4. Because this is where my zeros would be for my cosine. For my secant, these are now my asymptotes. Does that make sense? Oh, how to remember that there are zeros. I love that you asked. So remember, for when you're graphing cosine, we're making a cup, right? So our cup, we start our max, our 0, our min, our 0, our max. That's what's going to form our cup. Okay, so this goes back to 3b and remembering how to graph the cosine function. And from that cosine function, we know that our vertical asymptotes are its x-axis, or its secant, or its reciprocal. So wherever I hit, that's where my vertical asymptotes are going to be. So my vertical asymptotes are at the zeros, or at the x-intercepts of my cosine. And clearly it's going to be at C. Okay. So if I had to create the graph here, I could. I just drew in the asymptotes, and then you would draw in your opposite maxes and mins. Okay, but because it asks for the vertical asymptotes, all you're looking for is where are your x-intercepts in its cosine. The x-intercepts are going to tell you your vertical asymptotes. Yes? Okay, let's practice again. This time we're going to use sine. Okay, so we have here 4 minus 2 cosecant pi x. Which of the following is a vertical asymptote? Okay, these two are cool and important if it was talking about anything vertical, right? But we're not worried about vertical. We're only worried about what's happening on the horizontal. That's because when I'm looking for the vertical asymptotes, I'm looking for the x-intercepts of the sine. So the x-intercepts of the sine function is what we're worried about. For sine, as if it's positive, then it's going to, remember, our positive sign goes, and if it's negative, it goes. Okay, so because this is a negative cosecant, we know that it's going to be the negative sign. Does that make sense? So it's the negative cosecant. So we're going to be focused on the negative sign shape, which means we start off as an x-intercept, a min, an x-intercept, a max, an x-intercept. Okay? So we're going to create our line. All we have to do is figure out what is our b, our period. So our b is pi. So therefore, period equals 2 pi divided by b, which equals 2 pi divided by pi. So what is our period? 2. Our period is 2. So we're going from 0 to 2. We divide into quarters. What's half of 2? 1. What's half of 1? 1 half. 1 half plus 1 makes 3 halves. Now we have all of our quarters, and we're just going to place things how they're supposed to do, where they're supposed to go. So because this is a negative sign function, we know that we start off with our x-intercept, then we're going to have our minimum, then we're going to have our x-intercept, then we're going to have our maximum, and then we're going to have our x-intercept. So here's the sine function. Is that drawn pretty? No, but you get the gist of it. You see what's happening. Okay? Because we're looking for the vertical asymptotes, we're looking for the x-intercepts of our sine function. So everywhere there's an x-intercept, that's where our vertical asymptotes for the cosecant would be. We're here at 0, we're here at 1, and we're here at 2. And then it would continue, obviously. Now we can see the pattern. We would have an asymptote at every 1, 2, 3, every integer, right? So therefore the answer would be D. All right, questions, comments, concerns? Doable? All right, let's keep it going. Okay, now we are on to range. So your range, again, we're going to think of everything as its reciprocal. So we're at cosecant. Its reciprocal is going to be sine. All right, so its reciprocal is going to be sine. Did I ever tell y'all how I remember them? Okay, so this is going to be the most nerdiest thing. No, probably not. So do y'all remember Sakatoa? Right? So the whole Sakatoa called another hippie tripping on acid. That's Sakatoa. So for sine, its reciprocal is cosecant. And cosecant is H over C. So nothing is matched. You're going to always be opposites. Every S has a C. Every C has somebody else. C is going to be S, and it's always a reciprocal. Tangent is going to be also a C. C has somebody else. And then we have opposite over adjacent. So every S has a C, but C has somebody else. So that's how you remember. Don't put them together. C does not go with C's. S's does not go with S's. But every S has a C, and C is going to always have somebody else. And that somebody else is tangent because it's cotangent, which just gives it the same way. Okay. So just remembering that's how, and because we have to know the ratios as far as advanced algebra 2 went, but remembering boom, boom, boom. If you remember Sakatoa, every S has a C, every C has an S, and C has somebody else. Okay. And that's how you're going to remember who goes with what. So when I'm at cosecant, it is not cosine. Cosecant goes with sine. Okay. Yeah. Questions? Now this is where it gets weird. So, I write, right? And That probably doesn't sound like it's saying Cot to you. But in my mind, I was a very big Harry Potter nerd. And if I said it that way, it made me felt like I was a Passelton, like I spoke to snakes. So, yeah. So 15-year-old Shauna walked around and said, and that's how I remember the order that they went in. But it started off as that. And then, and that's how you remember. So now you know my brain out loud is away. All right, so now let's talk about cosecant. So cosecant means we're looking at actually what? We're actually looking at sine. So we're actually going to be looking at sine to figure out what the Hades is going on with this function, all right? So again, always think about its reciprocal. So starting off with sine, and we're going to sketch out the sine graph, all right? Because we're looking at range, we also are going to go ahead and sketch out the full graph itself. Does that make sense? So going back to 3b, and what does that mean? So the first thing we can do is we know that our midline is at 0. I'm going to draw this in, and our midline is at 0. Done. We know that our amp is what? 3. So we're going to be 3 units from 0 to the top and 3 units from 0 to the bottom. Y's are done. Questions about the Y. We find our midline, apply our amp, Y's are done. Okay, next is going to be our period, and our period is going to be, our period equals 2 pi divided by our B. In the case of this is pi over 2, so therefore our B is 1/2. If it's pi over 2, then our B is 1/2, right? Because it's the same thing as where it's saying 1/2 times pi, 1/2 times theta. Because theta is your unknown, it's your angle, instead of putting at x. Since it's a function, and it says that your function is defined as h of theta instead of h of x. So can I go back real quick? So you see here how we had g of x, and that's listed as x. Your variable is an x. Whatever is inside of your function notation, that's the name of your variable. So our variable is theta because it says h of theta. So theta is just an x. If that bothers your soul, make it an x. But theta just means an unknown angle, specifically an unknown angle. But if it bothers you, then turn it into an x. It's just a variable, just a Greek variable. All right, everything else is going to be the same though. This is a positive sign, so we know that we're going to go, that's our positive sign, correct? Plug in what we do know, we have 2 pi divided by 1/2. 2 pi divided by 1/2 is keep, change, flip situation here, right? So therefore our period is 4. Agreed? So we know that this is going to end at 4 pi. What's half of 4 pi? 2 pi. What's half of 2 pi? 1 pi. What is 1 pi plus 2 pi? 3 pi. So we've now found all of our key parts. Because we know what shape we're creating, we're going to go follow the rule. We have our x-intercept. So x-intercept, max, x-intercept, min, x-intercept. X-intercept, max, x-intercept, min, x-intercept. That's our sine function, but we're not graphing the sine function. We're analyzing it as a cosecant function. To find the cosecant function, you're just simply going to draw in your vertical asymptotes, and at your max and your mins, draw their reflected curves. Does that make sense? So if I'm concave up, then I'm going to be concave down as the reciprocal. If I'm concaved up, down, I'm going to be concaved up as a reciprocal. So we're going to draw on our reciprocal. This is an x-intercept, so it becomes an asymptote. This is an x-intercept, so it becomes an asymptote. This is an x-intercept, so it becomes an asymptote. This is concave down, so it's going to become concaved up. This is concaved up, so it's going to become concave down. And the red now is your reciprocal function. Does that make sense? Okay. So the red now is our reciprocal function, is asking us to define the range of that function. So the range of this function starts from bottom to top. So from the bottom, we are traveling up, and then, we got to stop. Where did we stop at? At -3. So we're going from negative infinity up until we hit -3, right? And then we go, jump, and I have to jump all the way to 3, +3. So therefore it is C. So now, after doing all this, can you tell me a pattern so you don't have to draw this? What do you notice a relationship between your range and your function? What is it tied to? It is tied to your amplitude, okay? The range of your function for a reciprocal trig function is going to be tied to its amplitude. Does that make sense? Okay. Now, it also would be tied to the midline. Our amp is not adjusted because our midline is at 0. But if we had a midline that wasn't at 0, what would it cause it to do? Remember, it's adding that value, right? So we would have to do a second step, but it's tied to your amp and your midline. Whatever your amp and your midline is, that's going to be your range. That's going to be the high and the low of your range. Does that make sense? Okay, if all else fails, could you go through and do the graph and then realize it yourself? Yes, you have plenty of time on the questions. They give you enough time. Some questions take like 40 seconds, and then therefore it's going to roll over. But in theory, you have about 2.3 minutes per question. Okay. And it shouldn't take you any longer to do that. And if you have time rolled over, we had people at the end of multiple choice who were done, they finished it and they had ample time. So I do love that if you do have extended time now, it allows you to exit once regular timing is up. So it doesn't no longer hold you in that space. It used to make you do the entire time just staring at the screen. I'm like, why are y'all doing this? All right, let's talk about cotangent. So cotangent, it's asking for the vertical asymptotes on the graph. So for cotangent, do you guys remember our cotangent graph, the original function? A little bit? Yes, that's the, not the cotangent, I'm sorry, tangent. So let's go look at her. So remember, cotangent automatically already had asymptotes. They automatically had asymptotes because it's sine over cosine, and cosine has asymptotes at certain values, correct? So when we have our cotangent, we're going to graph tan first, tan of x. So here's our tangent graph. Our tangent graphs already has asymptotes. Those asymptotes are at pi/2, and it's pi reciprocal, and a pi later. And that's because we're at pi/2, we're at 3 pi/2, we're at, I call them odd halves. Does that make sense when I say odd halves? Because it's an even half, it's going to be a whole number, but it's at the odd halves. So it's at 1 pi, 1/2, 3/2, 5/2, 7/2. It's at your odd halves. And so this is its regular function. And notice that it's increasing from left to right. When you have your cotangent, graph cotangent. And again, remember, if you're using Desmos, it's lazy and it allows you to type in. Cotangent, it's going to flip. So I'm going to hide it for a second. Your cotangent, its asymptotes are now defined by your sine function, where sine equals 0. So sine equals 0 at your whole pi's, at your 0, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. And that's where that flips at. Okay. This changes along with your period. The relationship for cotangent is our period is not, our b does not equal 2 pi over b. It equals pi. Okay, it's pi over b because that cycle for this to repeat is shorter. It's only 1 pi. Okay, so as you can see, this is from 0 to pi. This guy over here, turn him back on. It is from, we go from negative pi/2 to positive over pi/2. A half and a half makes a whole. My period is only 1 long. Does that make sense? So when we're finding that where those intercepts are, remember, it's shrunken. It's not over 2 pi, it's over just pi. So I'm going to graph it, and then we're going to talk about how you do it without graphing, because this would be a non-calculator problem. But sometimes seeing it visually and drawn better than your teacher can helps. Oh, goodness gracious. We're going to zoom in on that because that was a lot. I don't like how this looks either. Oh, because the baby's got smaller. All right. So as you can see, it's now shrinking those lines, but we're going to do it by hand because this is not helping us. And this doesn't have the lovely trig feature like Sylvie does. So we're going to do it by hand. How was our period affected? So our period equals pi over b for cotangent and tangent. It's not 2 pi because tangent happens every pi. Got it? So it's pi over b. Our b here is 2 pi. So this leads to us having pi over 2 pi. That means that this function is going to be happening every half unit. So that's why there were so many of it, because every half unit, you're going to be getting that. That means swirl. That sound effect is how that goes. So every half unit is where this is taking place. All right. So when we draw that, we're going to zoom in on her. No, it's a unit. It's just a unit, 0 and 1/2. Like it's counting. Let me see if I can, maybe if I change that so we can not be in pi mode. Click home. Did I click home? Little house. Is there no house? Huh? Oh, that's terrible. What is this at? Is that 10? That didn't help us at all. That help? Does that say 0.5? It does say 0.5? Jesus, good googly moogly. Okay, we're just gonna roll with it. You can see the values though. Why is it so tiny? Is it my vision? All right. What I wanted y'all to see is that the 0.5 in this case, because this is where our asymptotes would have been here for tangent. As you can see here, it's now going to be the asymptotes for your cotangent. And I don't know how to make this prettier. Like, how do I adjust this window to show it? Let's see. Let's try this again. I just want you to see that period part is going to be our asymptote. -5, cotangent, 2 pi. Yeah. Oh, Jesus. Is it the right? Maybe it is the range. What is the range at? A lot. Uh, Let me just be at 1. That didn't help. You know what? Forget this. Where's Sylvie? The bell's going to ring. But anyways, the goal here is for you to see that it is tied to, just wish you could see the asymptote where it's stopping at. But it's tied to, when you're doing it as a tangent, you're just changing that b factor. And that's going to tie to where your asymptote is going to take place. Your asymptote is going to be the opposite of where that b value is. So when we were at a half, notice that your asymptotes are here now at a half versus it being the period of your tangent. That's all I need you to know, the opposite of her. That got weird. We're going to have to pause.